Malware is kind of like a sleeper agent, right? It's just sitting there, silent, inside a network, just waiting for instructions. But how does it get those secret orders without tripping all the alarms? That's exactly what we're diving into today. The secret channels malware uses to communicate, hidden in a place you'd probably never even think to look. Yeah, that's the million-dollar question for every cybersecurity pro out there. How does this digital sleeper agent, phone home to its masters for commands? The answer is surprisingly simple and honestly kind of brilliant. It hides its messages in something we all use every single day, the internet's public mail system. Yep, the domain name system, or DNS.
So how exactly do they pull this off? Well, here's our game plan for this explainer. We'll start by uncovering this hidden channel itself. Then we'll dive right into the attacker's playbook, how they abuse the rules, play hide and seek, speak in code, and of course, always have a backup plan.
All right, first up, the internet's hidden channel. To really get how attackers hide their messages, we first need to understand the postal system they're using. Okay, first concept you gotta know is command and control, or C2 for short. Think of this as the brain of the whole operation. It's mission control. It's the server that's sending out the orders, steal this data, spread to that computer, launch an attack now. Without C2, the malware is basically just useless, dormant code. And this is the system they hijack to do it. The DNS. It's basically the internet's giant address book. Every time you type a website into your browser, DNS is the thing that translates that friendly name into a bunch of numbers, an IP address that computers can actually understand. It's absolutely fundamental to how the web works.
So why on earth is this address book the perfect spot for a secret channel? Simple. It's everywhere, it's trusted, and most security systems they overlook it. They expect to see tons and tons of DNS traffic, so it's the absolute perfect place to hide malicious messages right out in the open. It's like hiding a secret message on a totally normal-looking postcard.
And this right here, this is our map for the whole explainer. This taxonomy breaks down all the major ways attackers use DNS for C2. We're going to walk through this whole thing piece by piece so you can really understand their playbook.
Okay, let's jump into the first bag of tricks. These are probably the most direct methods, where attackers just take the normal rules of DNS and, they bend them to hide right in plain sight. We're starting right here with protocol abuse. This is all about smuggling data inside what looks like a totally normal address lookup. So how does this work in practice? Well, with something called DNS tunneling, they encode commands into these really long, weird-looking domain names. It's like sending a secret message one letter at a time. Or they might use special record types like TXT records. Think of those as a little blank note field in the DNS address book, a perfect covert mailbox for dropping off instructions. No matter the method, the goal's always the same: make the bad stuff look like boring everyday traffic.
But, hiding in plain sight doesn't work forever. Defenders eventually catch on, and that's why attackers have to play this constant game of cat and mouse. If their C2 server stays in one spot for too long, bam, it gets blocked. So the rule is simple: never stay put.
And that brings us to our second category, dynamic resolution and resilience. This is all about evasion through constant, relentless movement.
The whole strategy here is just make the C2 server a moving target. Instead of one static address that defenders can just blacklist, they use a whole bunch of clever tricks to make sure it's never in the same place twice. Take DGA, for example. It's a classic. The malware is programmed to create thousands of new, random-looking domain names every single day, all based on a specific algorithm. Now, the attacker knows that same algorithm, so all they have to do is register one of those thousands of domains, and boom, the malware phone's home. It's just like having thousands of disposable phone numbers and just waiting for the right one to connect. Fast Flux DNS kicks this up a notch. With single fast flux, you're constantly changing the IP addresses behind a single domain name. But double fast flux? Whoa, that is next level. It changes not just the IP address, but also the name server that's in charge of the domain. That adds a whole other layer of misdirection that makes tracking the real source an absolute nightmare. Okay, so what if defenders get wise and start actually inspecting the content of the DNS traffic? Well, attackers have a plan for that too. They just speak in code. They use encryption. And that takes us to the blue section on our map, encryption and evasion. This is where things get really clever, because attackers start using technologies designed to protect our privacy as a shield for their own secret chats.
So you've got these technologies, right? DNS over HTTPS, or DOE, and DNS over TLS. They were created for a great reason, to encrypt your DNS queries and protect your privacy. But that same encryption can be hijacked by malware to completely cloak its C2 communications. To any security tool, it just looks like normal encrypted web traffic. It blends right in. All right, last but not least. No smart attacker ever puts all their eggs in one basket. What happens if their main DNS channel gets found and shut down? They've got to have a plan B. And that brings us to our final category here, fallback and hybridization. This is all about resilience, making sure the malware can phone home no matter what. This one's pretty straightforward, but really effective. The malware might try DNS first, but if that doesn't work, it can fall back to a more direct connection, like to a hard-coded IP address. Or it'll just use a hybrid model right from the start, using both DNS and direct connections to make sure that link to mission control is never, ever broken. So, after all that technical detail, why does this matter so much? Because you can't fight what you can't see. The internet's simple, trusted address book has been turned into this incredibly complex, invisible battlefield. And knowing the enemy's tactics, well, that's the first and most important step to actually defending our networks. So, what should you really take away from all this? 1. Attackers love to abuse the systems we trust the most, like DNS. 2. Their evasion techniques are always evolving. They're always hiding, moving, and encrypting. 3. Malware is built to be tough, always with a backup plan. And finally, if you're a defender, this means you need deep visibility into all your network traffic, especially the stuff that looks the most harmless. And that leaves us with one last big question to think about. We've seen how attackers are hijacking privacy tech like encrypted DNS. So as the entire internet becomes more private and more encrypted by default, where are they going to hide next? What's the next invisible battlefield?